solving problems using Venn diagrams. Do not forget to subscribe, and if you have any question about union or intersection of sets, you should watch this video before continuing. One of the most interesting features of Venn diagrams is the areas or sections where the circles overlap one another, implying that a sharing is occurring. This ability to represent a sharing of conditions makes Venn diagrams useful tools for solving complicated problems. You may be asked to solve problems using Venn diagrams in an exam. You must draw the Venn diagram and add the given information to populate the diagram and figure out the remaining information as you go along. Consider the following example. The number of people in a sports club is 75. The number of people that practice tennis is 42 and plays hockey is 53. If 27 people play both sports, how many people do not play either sport? There are two classifications in this universe: people who play hockey and people who play tennis. Let's draw a Venn diagram to represent the situation described in the problem. Let T be the set of people who play tennis and H the set of people who play hockey. The universal set includes all 75 players. First, we will draw two overlapping circles and notice that the overlapped part belongs to both hockey and tennis. We can place the 27 players who are playing both sports in that overlap. The problem says 42 people play tennis. But from the diagram, 27 people play both sports. So the number of people who play tennis and not play hockey is 42 minus 27. So we will put 15 in the tennis only part of the tennis circle. 53 people play hockey, but 27 of those players also play tennis. Therefore, there are only 26 people who play hockey and not tennis. We will put 26 in the hockey only part of the hockey circle. This tells us that a total of 68 people are in either tennis or hockey, or both. Since there are 75 people in all, 75 minus 68 of them do not play tennis or hockey. This answers the question. We will put 7 inside the rectangle, but outside the two circles. A language class has 24 students, of which 18 are learning French and 12 are learning Spanish. If 4 learn neither language, how many learn both languages? Let the universal set be the class of 24 students. Let F and S be the sets of students learning French and Spanish, respectively. We will draw two overlapping circles and notice that the overlapped part belongs to both French and Spanish. The easiest strategy is to start at the center, the part where the two circles overlap, just as we made in the previous example. In short, we start from the inside out. As we do not know the number of students who learn both languages, we can place the letter X in that overlap. We know that 18 are learning French, so 18 minus X are learning only French. So we will put 18 minus X in the French only part of the French circle. We know that 12 are learning Spanish, so 12 minus X are learning only Spanish. So we will put 12 minus X in the Spanish only part of the Spanish circle. We know that 4 of them are not learning either French or Spanish, so we will put 4 inside the rectangle, but outside the two circles. The total number of students is 24, and adding together all the expressions on the Venn diagram gives 18 minus x plus 12 minus x plus 4 equals 24. Solving for x, we get 10. Therefore, 10 students learn both languages. In a senior class, all the students were asked which of the following subjects they take this semester: mathematics, English, or biology. The headmaster is informed that below is the result of the survey. How many students are there in that senior class? Let the universal set be the senior class. Let M, B, and E be the sets of students taking mathematics, biology, and English, respectively. We started with the overlapping circles. In this problem, we have 4 regions which overlap. The easiest strategy is to start at the center, the part where the 3 circles overlap. In short, we start from the inside out. 5 students responded that they took all the subjects, so we can place 5 at the center. 7 responded biology and math. However, of the 7 who takes biology and math, 5 were also taking English. So there are 7 minus 5 students in the math-biology overlap. 8 responded biology and English. But of those 8 taking biology and English, 5 are also taking math. So there are 8 minus 5 students who are taking biology and English. There are 10 students who are taking math and English. And of those 10, 5 are also taking biology. So there are 10 minus 5 who are taking math and English. "18 students responded biology, but notice that 5, 2, and 3 are already in the biology circle. So we subtract those students from 18. So there are 8 students who take only biology. There are 15 students who are taking math, but notice that 5, 2, and 5 are already in the math circle. So we subtract those students from 15. There are 3 students who take only math. 15 students responded English, but notice that 5, 5, and 3 are already in the English circle. So we subtract those students from 15. There are 2 students who take only English. 3 students responded in neither subject, so they go outside the 3 circles. Now we add together all the numbers on the Venn diagram to get the total of students.